Now we need to do nomenclature. And this is where the rules for this nomenclature, I think, actually could spill backwards into some that we've done already, where we talk about priorities. These priorities that are listed, and that I'll show you in a second. In fact, I think I've given you a handout on priorities, haven't I? I believe I have.
Yes.
Yeah. So the priorities here reference which functional groups are applied to the suffix of the name. So if you have methane with a hydroxyl on it, you're going to call it methanol. OL stands for alcohol. That type of thing. And you need to know the priorities, and that's why the fourth exam will probably be open book too. So you can use this list of priorities and get them straight. When you start to name the compound, you have to have the correct priorities in order to determine what's your longest chain. Okay, so when we look at it in those terms, we can break the name of the molecule down into a root, a prefix, and a suffix. So the prefix we're familiar with. It indicates what substituents you have and where they're located in the molecule. The root is the parent. That indicates the longest chain or a ring of carbons, and the presence of double and triple bonds. Right? And the double bond takes priority over the triple bond when you're determining the longest chain. But the suffix also has a priority that exceeds the functional groups that are applied to the suffix, has a priority for them that exceeds the double and triple bonds. And as I understand it, the general concept behind the priorities of these functional groups is the more reactive has higher priority. You can look at it in those terms. So you would see that carboxylic acid is highest priority of all of them. And that is supposedly the most reactive. Okay. So we have to determine the highest priority functional group that's present. You identify your functional groups, and then you look for the highest priority. Then you have to establish which is the main chain or the main ring. It has to contain the highest priority functional group. Right. So you may be looking at if you have this high priority functional group, or you have more than one functional group, then the highest priority is going to determine which can be the longest chain. And that may not be the longest chain that's in the molecule. It's the longest chain with the priority group. Okay, that's another caveat. Then you take that, once you've determined that, then you get the suffix. In other words, the suffix is based upon, well, it should be in that priority group. You know, what's the suffix for each one? And in fact, it's on an upcoming slide, so I'm not going to beat that horse anymore. But for aesthetic purposes, we remove the E from the alkane, alkene, alkyne. Just take the E off of the ending before you add the suffix. And of course, there's an exception, and that's for nitriles. Then you number the main chain or ring based upon our previous assumptions. You want the lowest combination of numbers for the substituents. And then within the molecule, within the preceding the suffix, you want to say where in that molecule does the priority group occur, because it may not be on the first carbon. It could be on one of the other carbons because you have to reduce the numbering system to this minimum. Then that may put the highest priority group at some other carbon besides 1. It may be 2, 3, or 4. Then you add the prefixes that locate the rest of the functional groups. Okay, here we go. So if we have a carboxylic acid in there, that's definitely that carbon with the carbonyl and the hydroxyl is the highest priority of any. That's the easiest one to do. I don't think we're gonna visit anhydrides very much. The reason anhydrides are high priority is because they split so easily and they produce carboxylic acid plus a reactive species. Next term we'll use an acid anhydride in a reaction. I think it's to make aspirin. We'll use acetic anhydride. So the ending for the carboxylic acid will be oic acid, something oic acid. And then the oic anhydride would just be the derivation of that one. There's a special way to name esters that's coming up in a later slide, so we'll postpone that one till later. Chlorocarbonyl is for the acid chloride. So that's like taking the hydroxyl off and replacing it with a halogen, which is usually chlorine. The amide, we know what an amide is. Carbam oil is the, actually the ending, excuse me. The ending is amide. I confused you on that previous one too. It's not chlorocarbonyl, it's oil carbon chloride. And then we just go down the list. Lowest priority in this list is the amine. I think there's more to it than that. That's not the whole list. Well, that is the whole list for suffixes, endings. All right, so the lowest is amine. The next to the lowest is alcohol, the OL. And the best way to learn them is just use them. So if we go to alcohols and amines, we're going to work backwards from the least priority to the higher priorities. So for example, we have this very simple molecule, the first one, where we have the propane and we add an OH group to it. And it's on the first carbon. That gives us the smallest numbering system with the alcohol at the number 1. So that would be propane 1-ol. I think in the past, we used to say 1-propanol. But things have shifted over time. If we move that hydroxyl to the second carbon, then it's propane 2-ol. Now, what if we moved it to the third carbon? It's sort of a trick question. It's the same as propane 1-ol. Right? Just flip the molecule around. Ethanol is based upon ethane, so we drop the E and add the OL. Ethanol that's it. That's all it can be. It doesn't have any other possibilities. You don't need a locator number. And cyclohexanol, right? You don't need a locator number there either, because there's only one functional group, and it could be on any carbon, and that would be the number 1 carbon. Okay, so let's go to the amines. So that first one, we find the longest chain with the functional group, which would be the whole chain. It would be 1 through 5. So that's pentane. And then where is the amine located? It's on the third carbon. So it's pentane 3-amine. The suffix is the amine, and it's located on the third carbon. cyclopentanamine, right? Put it anywhere. You don't need a locator number on that one because there's only one. The next one, though, you have a cyclopentane amine, and you don't have to locate the amine because it's always on the first carbon in this situation. Well, which way do you number it? Well, if you number it to counterclockwise, you got 1, 2, 3. All right, that works. If you number it clockwise, it's 1, 2, 3. 1, 2, 3. No, if you go counterclockwise, you number it 4. So you have to go clockwise to give it a 3-nitro. Stop me if you have questions. So that last one, the halogens, and I'm going to look back. I'm going to go back and look. Halogens are, well, this is functional groups that are suffixes and prefixes. But we understand that halogens are lowest priority. I think lowest priority, or maybe no, I think they are. I think halogens are the lowest priority. So we would simply say the longest chain with the amine in it gives us, and we want the amine to have the lowest number. So we start from the left. 1, 2, 3, 4, 5, 6. 6 is for the chloro. So 6-chlorohexane 3-amine is the proper name for that one. All right. Now we're going to get a little more complicated. Longest chain for this first one. Highest priority is the amine. Right. Second priority is the alkene, the cycloalkene. And the lowest priority is the chlorine. So our parent would be cyclohexane. Actually, cyclohex-2-ene. But the final one, the last one on the name, has to be the highest priority, and it's at the number 1 location. So in order to give the double bond the lowest possible number, we start with the amine and we go counterclockwise. So it's 1 amine, the 2-ene, and the 4-chloro. I think that makes sense. How about the second one? We've got an all and double bonds. We've got alkenes. Well, the alcohol is a higher priority than the alkenes. So we have to start from the end that gives us the lowest number for the alcohol. So the longest chain is what? It's heptane. That's 7 carbons. If we're starting from the right, then the ending is 2-ol. And then we got the double bonded carbons at 4 and 6. And those are dienes. Hepta-4,6 diene 2-ol. That's a mouthful. The last one might give you a pause. We know that the alcohol is higher priority than the alkyne, but we have to start from the end that gives us the lowest value for the alcohol. So that means we start from the right end, and that also gives us the lowest value for the alkyne too. So that one's obvious. We would not start from the left. So hep-1-ine 4-ol is the proper name for that one. Okay. In this first example here, we have a higher priority is the alcohol. Lower priority is the amine, so it has to be a prefix. The suffix to the name is the higher priority, which is the ol. So we count from the right to give the suffix the lowest possible number. 1, 2, 3, 4, 5. So we have pentane or pentane 1-all. And then the prefix is 5-amino. All right. This last one looks like a real hairy one. Right. We know that we're going to have a cyclo of some kind. So we have what? 6. So it'd be cyclohexane. And the highest priority there is the alcohol. So it'd be hexane-all, cyclohexanol. Now, how about the numbering system? We want the lowest possible numbering system, starting with the alcohol, and we'd have to go clockwise. So now we have, let me put this one on the board. So we have cyclohexanol, got that one established. And if we number to the right, then we're going to have 2,2-dichloro, 2,2-dichloro. And we're also going to have 3,4-diamino. 3,4-diamino. Now we go in, now we get the alphabet rule. Right? A amino comes before chloro. So the 3,4-diamino comes first, then the 2,2-dichloro comes next. That wasn't as hard as I thought it would be. Okay. So if we've got this, the first example down there has 2 hydroxyls in it, and the hydroxyl beats the amino. So we have to have it all on the end, but we've got 2 of them, so we have to say diol. And the lowest numbering system that would give us both of those in that carbon chain would start from the right and would give us a 2,4-diol. And the chain itself is 5 carbons long, so that's pentane 2,4-diol. I noticed they kept the E on there. Yeah. If the all comes directly after the pentane, it would be pentanol. But since it doesn't, then we keep the E. I think it's more aesthetic than it is anything. It just doesn't sound right if you don't keep the E. And then at the end, the 5th carbon is the amino. That was fairly straightforward. What if you don't have a higher priority than the amine? Well, in this cyclohexane, then we have 3 amines in there. So how would we number those so that we give the lowest numbering system for the amines and still include the chlorides? Let's see. If we number if we counterclockwise from the lower right-hand side, that would give us very low numbers. If we started on the middle amine, then the last amine would be a 6, so that wouldn't work. If we started on the lower right hand and worked to the left, that would give us 1, 2, 3, 4, 1, 4, 6. That would be too big. So our only choice is to start on the amine to the lower right and work counterclockwise. That gives us the lowest selection of numbers. So 1, 2, 4 triamine is the suffix, and the 3,3-dichloro then would be our prefix. Okay, that makes sense too. Okay. Now Dr. Carty's throwing a real monster at us here. 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 in the zigzag. That's 1, 2, 3, 4, 5, 6, 7, 8. This one's a double bond. This one's amine. Okay. This one's hydroxyl. This one is a methanol. And this one has another thing. Okay. So there are any functional groups that require suffix? Yeah. We have a competition between the hydroxyl and the amine. The hydroxyl wins. So what's the longest carbon chain that contains the highest priority group? Well, let's see. If we did 1, 2, 3, 4, 5, 6, that would include this hydroxyl too. If we did 1, 2, 3, 4, that doesn't include this one. So we have to, this is a method that Leah Forsyth suggests is the shading method. So she says shade it like this and this and this. That identifies your longest chain that has both of the high priorities in it. So this is one of those cases where it's not actually the longest carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. It would be an octane if we didn't have this hydroxyl. But since we have that hydroxyl, it has to be part of the main chain. So that means we've got 1, 2, 3, 4, 5, 6. So it starts with hexane. And the numbering system that will give us the lowest number for all of our groups would be which end? We'd start on this end, wouldn't we? 1, 2, 3, 4. 1, 4. Diol. If we started from the other end, 1, 2, 3, 4, 5, 6. That'd be 4, 6. So we have to start from this end. That's 1, 2, 3, 4, 5, 6. Okay. So that gives us hexane 1,4-diol. Now the amine happens on the fourth carbon. So we got 4 amino. But we also have, what's this? This is longest chain here. 1, 2, 3. So this is propane. With a methyl on the second. So it's 2 methyl propane, right? And that should be in parentheses. Oh, and we got the last carbon-carbon bond. So that's going to be a, that would have to go in here. Actually, it'd have to fit right in there. So it'd be hexane 1, hex 1, excuse me, hex 1 ene 1,4-diol. And then we get these prefixes. Okay. Now, why'd they number it backwards? 1, 2, 3, 4. 1, 4. I suppose that we want the amine to be a higher priority than the ene. That's the only thing that makes sense. We number it backwards the other way, then 1. Yeah, because that's going to give us a 3 here. If we number it backwards like that, then this is going to be 5. Excuse me. No, that's not it. This is going to be 1, 2, 3, 4, 5. 5E. Okay, so 3 amino. 3 amino, because A comes before M. So we need 3-amino out here. 3-amino. And then attached to the number 2, so I got to number these backwards. 1, 2, 3, 4, 5, 6. This would be attached to the 2. And this would be 2 within this methylpropyl, 2-methylpropyl. So that's propyl. So this would be 2-methylpropyl. And then we'd have the hex 5-ene-1,4-diol. Now, have you been reading this while I've been chattering? Why did we number them this direction? There are 2 hydroxyl groups. The longest carbon chain that contains both of them has 6 carbons. Okay, we know that. Chain is numbered so the first OH encountered receives the lowest possible number. Oh, okay. Yeah, I numbered them from the wrong direction. We want the first high priority group to be the lowest number possible. Okay, so that makes sense. Did I confuse anybody? Does that make sense now? Huh? Yeah, I was working from the wrong direction. Yeah, I was working from the wrong direction. All right. I'm glad we were given that problem. That straightened some things out. Okay. So when we have molecules with more than one alkyl group bonded to the amine nitrogen, if it's just the amine attached to as some functional group, then that's simple. But if we have more than one alkyl group attached to the amine, we use the same idea here as we did with the carbons. If you have a carbon attached to one other carbon, it's primary, 2 other carbons, it's secondary, 3 other carbons, it's tertiary. So with the nitrogen, you can do the same thing, right? Primary is attached to one other alkyl group, one other carbon. Secondary has 2 carbon attached, and tertiary has 3 carbons attached. Use the same concept there. In this case, what we have to do is establish which alkyl group attached to the nitrogen establishes the root. Which one, if it's amine, right, and it's the primary, right, then we have to establish the longest root of the R group that's attached to the nitrogen. And then you treat the other alkyl groups as prefixes. All right, so here's an example. In this case, in this first case, we have a cyclohexene attached on one side and a methyl on the other side. So in order to, which is the longest one attached to the nitrogen? Well, it's the cyclo. It's the cyclohex-3-ene. And the since the amine is the highest priority, it has to be attached at the number 1 carbon. So it's the 1 amine. Okay, so it's a 3-ene and 1 amine. That gives us the lowest number for attachment of the amine and for the cycloalkene. Now, how do you identify other groups that are attached to the nitrogen? You say N-methyl. If you don't say N-methyl, then we think the methyl is attached to some other carbon. So we say N-methyl shows that the amine has another group attached to it. another alkyl group attached to it, and that group is N-methyl. That was for a secondary amine. For tertiary amine, we're still going to use N in our prefix, but we're saying at the end, we've got both an ethyl attached to it and a methoxy attached to it, because the main chain is, let's see, the main chain includes the lowest number that will include the amine. So we number from the left, 1, 2, 3, 4, 5, and then that's the longest chain. That also includes the other functional group. Okay, so we have a pentane, 2-amine. So the amine is attached to the second carbon. And we have, let's see, what else do we have? We have a methoxy. Now we're looking at, maybe I better put this on the board. We've got the pentane 2-amine already established. Okay, pentane 2-amine is already established. Now we have, let's see, how many methyl groups do we have in that molecule? We have 2. One is attached to the third carbon, and the other is attached to the nitrogen. So we have to say one of them is here, one of them is here, and it's dimethyl. Okay, that takes care of those. Now we also have a methoxy that's attached to the 5 carbon, so it's 5-methoxy. And the last one that we have to deal with is the ethyl group, and it's attached to the nitrogen. So that's N-ethyl. So there are substituents. Now we have to order them by alphabetical. So this is M, methyl methoxy. Oh, excuse me. Yeah, dimethyl. M is last. Then 3. Which comes methoxy. They're putting methoxy before. Oh, methyl. Okay, alphabetical. That Y right there is beat out by that O. So the meth Y is after meth O. And then E comes before all of them. So now we have N-ethyl. And then this one, 5-methoxy. And N-3-dimethyl. Pentane 2-amine. Yep. Okay. That took some doing. Now, the next priority we're going to look at is those that have carbonyl groups in them. Ketone versus aldehyde. For an aldehyde, well, you've got the carbonyl group here, right, like that. Then you can have something else attached to that carbon, because carbon can have 4 bonds to it. So 4 bonds. Now the question is, if it's a ketone, then you've got a carbon group here and a carbon group there. That's a ketone. And its suffix is going to be ONE. If it's an aldehyde, then that carbon still has the carbonyl group, but you've only got 1 R over here, and you definitely have an H there. Now, in one example, both of these can be H's. Right? Both of those can be H's. And in that case, this is an aldehyde. And if they're both H's, that's formaldehyde. but all other molecules have a carbon group on this side. And that means this will be on the end of the molecule. It'll be a terminal. Whereas, and the suffix is AL. Suffix here is ONE. In this case, you can have the ketone can be anywhere in the molecule, except on the end. Okay. So the first example there, its IUPAC name is propanone because it's based upon propanol, and the carbonyl group is on the second carbon. But notice that if it were on the first carbon, it would be propanal, not propanone. If it was on the first or the last carbon, it would be propanal. So in this case, since it's on the middle carbon, we don't have to say what the number is. It's just propanone. And grandfathered in, you can also call it acetone. For the second one, we've got a mix. We've got an alcohol and we have a carbonyl group. Now, which was higher priority? Well, we're sort of moving up the list. So the ketone is a higher priority than the alcohol. That means that the chain, the longest chain with the ketone is the one that establishes numbering. And we number from the right because that gives the smallest number to the ketone. So 1, 2, 3, 4, 5, that's pentane 2-one. And then the prefix is the 4-hydroxy. Let's see. What about this other one? The longest chain that has both of the ketones in it. So it's 2,4-dione. We're going to number from, actually, it doesn't matter which side you number from, does it? You're going to get the same numbering system, 2 and 4. And 3 is right in the middle. So it's irrelevant. Number from the right or the left, you get the same outcome. So 3-propyl, 2,4-dione. Now, we don't have to say which carbon is attached for the propyl, because when you say propyl, you automatically assume it's the first carbon on that propyl group. But it's attached at the third carbon. And then the dione is 2 and 4. Okay, that was fairly simple. How about the last one? This is a cyclohexane. And it has 3 carbonyl groups. Right? So all we have to do for this one is decide what gives us the smallest numbering system. If we go clockwise, that makes the last one a 6. If we go counterclockwise, the last one's a 4. That's the preferable one. Cyclohexane 1,2,4-trione. Aldehydes. Okay, aldehydes have a higher priority than ketones. And they always occur at the end of the molecule. So they're always going to be number 1. Well, I should take that back. That works for A, B, and C. Right, start number 1. But if you have a cyclic aldehyde, and amine is a lower priority. So we want the longest chain that includes the aldehyde. You know, as a practical matter here, I see that the longest chain, we can't say the longest chain is a methyl group because it has the aldehyde on it. So we actually have to modify the name and include carbaldehyde. The carbaldehyde is the CO group. But we still put it at the end of the name, cyclopentane carbaldehyde. All right. That's kind of a squirrely one there for me. Yeah, it's the size of the ring that beats out. But we still have to start numbering one on the end where you have the aldehyde. What if you had what if you had two carbons out there on that aldehyde? I don't know what to do with that one. Yeah. What do the rules say? Because it's not a longer chain than the cyclopentane. Cycloalkane carbaldehyde. It might. I don't know. So you're not going to see one of those on an exam if I can't figure it out. Not on my exam, in other words. All right. So here we are at the highest priority, carboxylic acid. So the ending is going to be oic acid always. And if you have more than one carboxylic acid, it's going to be dioic acid or trioic acid, as the case may be. Now we've thrown a curve in here. We've got a ketone, we've got an alkene, and we've got a carboxylic acid, an oic acid. That's going to be the ending. What's the longest chain that includes the oic acid and the other functional groups? Right. In that case, it's going to be decane. There are 10 carbons there. So dec 2, since we start numbering from the carboxylic acid side, the ene is going to be 2 and the oic acid is going to be 1. So that's fairly straightforward. And then at the end, the 9th position is going to be oxo, right? It's not a suffix, so we can't use own. Own is only for suffixes. So we have to say oxo for where's the oxygen attached. And in this case, we also, since we have a double bond in there, we have to say, is this an E or a Z, right? Is it on the opposite sides or the same side? Is it the opposite or the same side? It's not on the same side, so it's not a Z, it's an E. It's the opposite. And those designations, I'm pretty sure come at the beginning of the molecule. What about that last one? Okay. The longest one, well, actually, we have two endings there. We have a dioic off of butane. So it's butane dioic acid. And since the carboxylic acids always occur at the ends of molecules. So if we only have two of them, then the longest chain is the one that includes both of them. That's butane. And then off of the second carbon, we have what? 1, 2, 3, 4, 5. We have a pentyl. And since it's attached at the number 1 carbon on the pentyl group, then we only have to say pentyl. We don't have to say where it's attached. But this one is also introducing stereochemistry. So notice that what you have here, and I think this one would be a good example for the board. What you have here is this carboxylic acid. I put that carbon in there just for fun. Then we go here, here, and now we have on that carbon 1, 2, 3, 4, 5. Go. And then on the first carbon. We have OH there. But remember, we don't write the hydrogens in unless they're part of these functional groups. So there's actually a hydrogen here. And if this one is forward and these are in the plane, this hydrogen has to be back. Okay? The hydrogen has to be pointing back if this group is pointing forward. Okay, so now how do we do R and S? Remember that? We need to establish priorities from the Kahn-Engel-Prelog priority rules. And that's based upon, first, you go to the first available atom attached to the chiral carbon right here. That's a carbon, that's a carbon, that's a carbon. So we got to break a tie, right? So we go to the second one attached. So this one's a carbon. And let's see, this one's a carbon. That one's a carbon attached to two oxygens. So this one is highest priority. Hydrogen is going to be 4. This is going to be 1. And then we go, let's see, we went to this carbon, this carbon, this carbon. And then we went to this carbon, this carbon, this carbon. So this is going to be the next, this is going to be a 3. And this would be a 2. Since this one's only 1 carbon off, and this one's 2 carbons off, then this one is a lower priority. But this one's the lowest priority hydrogen. Then this 1, 2, 3, 4, this pentyl group. 1, 2, 5, yeah, pentyl group. So now, since hydrogen's in the back, we can establish clockwise or counterclockwise. So this goes 1, 2, 3. That goes to the right. Rectus, which is the R. Did I lose you on that one? Or just bore you to death? Takes a lot of practice, I know. How about, let's see, these were carboxylic acids, okay? These are nitriles. Nitrile, I'm not sure what priority nitrile is. The carbon in the nitrile functional group is always part of the functional group. Okay. The oil chloride would be a higher priority. So it's going to be the ending on the right-hand molecule. And the nitrile is going to be a higher priority than any of the other groups. Okay, so the molecule on the left, the nitrile is the suffix, and it includes 1, 2, 3, 4, 5, 6. That gives you 6 carbons in the alkane group, and the cyclopentane is a substituent because it's only got 5 carbons. All right, so we're going to say hexane nitrile. And then we're going to attach at the 4th carbon, the 4-cyclopentyl. That one's fairly straightforward. I like that one. But the second one, the oil chloride, is a much higher priority than the nitrile. So now we have to put the carbon triple bond nitrogen as a prefix. So now we start from the carbon that's the carbonyl group with the chloride. We start, that is number 1. So it's 1, 2, 3. And the point that we're trying to make here is that the longest chain is only 3 carbons long. Because when you include the cyano as a functional group, it's attached to the 3rd carbon. So that carbon happens to be part of the cyano. You don't count it as part of the chain. It's only counted as part of the longest chain when it's the highest priority. And now you have a nitrile. You see that difference, that distinction? So now the cyano is attached at the third carbon, 3-cyano propanoyl chloride. I think that was the primary point of this slide, is telling the difference between nitriles and those where the cyano is a substituent rather than a suffix. So here we have some more amides. Oh no, not amines, amides. So as a carbonyl and a nitrogen attached to one another. And this is definitely a higher priority than the triple bond in the first example. It's not a higher priority in the second one. All right, so it has to be a substituent. So in the first one, we're going to say that the amide and the carbon in the amide group is the number one carbon. So we go from that number one carbon and number across to 7. So we have a hept, and then 3, and we say 3, we have to say amide is the last part of the molecule, and the ine tells you where the triple bond is located. So it's hep3-ine amide. Okay, that takes care of everything except for what's attached to the nitrogen in the amide. So we have both a methyl and an ethyl attached to the N in the amide. So alphabetical, E comes before M. We have an N-ethyl and an N-methyl. We have to say N for both of them separately. Otherwise, you might assume that the ethyl or the methyl is attached to a carbon. Okay, actually, that was the easy one. So in the second molecule, we have a situation where the carboxylic acid is a higher priority. So we have to number the molecule, including and give it the smallest numbering for the attached amide. But in this case, we can't call it an amide because it's not a suffix. We have to use the prefix version for the carbam oil, right, attached at the number 2 carbon. So it's 2-carbam oil butane dioic acid. Now we can use the primary, secondary, tertiary considerations for amides. The first molecule that we looked at there was what? Well, let's see. It had 2 groups on the nitrogen, so that's tertiary. If we change one of them for a hydrogen, that's secondary, and an amide with only hydrogens attached to the nitrogen is primary. So we're consistent with that terminology. All right. This is L-asparagine, an amino acid. You see where the alpha carbon is the one which has the dashed offshoot from it. It has an amine group, it has a carboxylic acid group, and then it has the R group, the carbam oil, right? Yeah, carbam oil. Okay, so what's the IUPAC name for this thing? Well, let's see. We identify the highest priority is the carboxylic acid, right? And then we have an amino group, which is a higher priority, actually the amino group is a lower priority than the carbam oil. Three carbons, right? So it's propanoic acid. All right, we got that much. Propanoic acid. That means if we count from that number 1 position, now we've got the amine group at the number 2 carbon and the carbamoyl at the number 3 carbon. So it's 2 amino, alphabetical, 2 amino, 3 carbamoyl propanoic acid. I think that's why they invented asparagine, because it's easier to deal with. But this is also a chiral compound, right? That carbon is chiral. That number 2 carbon is chiral. And they're giving us they're using the L designator for this versus the D versus L. Levorotary versus dextrorotary. And that has to do with its optical activity. I don't think we're going to make a big deal out of that. We could go in and say, is this R or S? But I think we'll move on instead. So how about carboxylic acids on a ring? Well, that would definitely be the number 1 carbon. If you have a carboxylic acid on the ring, this would be hexane carboxylic acid. And then we would number for the smallest value for the substituent would be 3-oxo, cyclohexane carboxylic acid. That was the easy one. How about the second one? Well, we've got a cyclopent, but it's an ene, cyclopent-2-ene, and we number it to clockwise so that we give the smallest value to the ene from the number 1 position, and that's carboxamide. Since the cycloene is a lower priority, then we suffix the name with carboxamide. How about this last one? In this case, the longest carbon chain is going to be the cyclobutane. And we're attached to it a carbonitrile. So this is one of those cases where you have the nitrile, the carbon in the nitrile is not connected directly to, let's see, no, it is connected directly to the cyclobutane. Carbonitrile. I'm going to back up and look at that nitrile we had before. Here it is. Okay. We're treating that as the suffix. Okay. It's not just a nitrile, right? Because we have the cyclobutane. So we're saying that the nitrile is attached to the carbon, a carbon on the cyclobutane. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 carbons and 1 nitrogen. All right. Oh, esters and acid anhydrides. We had to save the ester till last. Because esters are, you can view them, an ester, as a derivative of a carboxylic acid. You just take the carboxylic acid and you replace the hydrogen on the acid hydrogen with an alkyl group. And the way you name it is actually the ester, if it's the highest priority in the molecule, then you end it with OATE. That's the ending. But before the ending, you name the alkyl group. So if the alkyl group is methyl, you say methanoate or butanoate. Oh, excuse me. Right. The alkyl group comes first. We have to say what it is. Okay, let me back up. The alkyl group comes first, and then we name the O8 group. And that depends on how long the R chain is. Okay, so back to this slide. So the longest chain that includes the ester group is 4 carbons. 1, 2, 3, 4. So that's butanoate. And then what's attached to that is the ethyl group. Or if it's ethanoate, then we attach the propyl group for the second one. Okay, does that make any sense? Okay. And you might have seen this before in other courses. They seem to be more common in other courses than some of these other molecules that we run across in organic chemistry. So here's another possibility for an ester. That first one, the longest chain that includes the O8 is 1, 2, 3, 4 carbons long. So it's butanoate. But at the number 3 position, we have 3-oxo. And then as the group that's attached on the oxygen has 3 carbons, so it's propyl. But at the 1 position, we have a methyl. 1 methyl propyl, 3-oxobutanoate. Okay. The last one is going to be a challenge because we have 2 chiral groups there. So maybe we better put that one on the board. I know I need it on the board. Can't just talk about it. All right, let me get it drawn correctly. 1, 2, 3, 4, 5. 5 carbons. 2, 3, 4, 5. Okay. Now for the 4 carbon, we have an OH. And off of the 3 carbon, we have another OH. And then off of the 1 carbon, we have a, oh, that's the beginning of our, there. Then off of this, we have phenol group. That, right? Okay. So we have a pentanoate. We have 5, and we number from here. 1, 2, 3, 4, 5. So we have a pentanoate. All right. Now, what's attached to okay. It if I interpret this correctly, the substituent that's attached to the oxygen of the ester comes first. So phenol is going to come first, way out here. And in between, we're going to have the other substituents. So we've got a dihydroxy. Okay. And they occur on the 3 and the 4. Right? 3, 4, 4, dihydroxy. But we also want to include a statement on their chirality. So that comes here in these parentheses. Right? We're going to say, what's the 3 and what's the 4? So we're going to have a 3 something and we're going to have a 4 something. So we need our priorities here. If this hydroxyl is pointing out, that means that hydrogen is pointing back. and this hydrogen is pointing back. Okay, so you always want the lowest priority pointing backwards. And then we look at the priorities. Right, so we have oxygen is a higher priority than either carbons. So this is going to be number 1. So if we go from here to here, this carbon has 3 hydrogens attached to it, whereas this carbon has an oxygen and 2 hydrogens. So 1 oxygen, 2 hydrogens beat it. This is a 2, and this is the 3. So 1, 2, 3 means S. So at the 3, we have an S. At the, excuse me, the 4, I'm sorry, I'm doing it backwards. The 4 has an S. How about the 3? The 3 is over here. So at this one, we have, this is the highest priority, 1. And then how about we go over here like this? This has a carbon and a carbon. So we have to go to the next. This has a carbon and an oxygen. Carbon and oxygen. And this carbon has 3 hydrogens. This one has double bonds give you two oxygens on this side. So this one takes higher priority on this side. So that means this is 1. Hold on a second. No, because the next one attached to this one is a carbon. The next one attached to this one is an oxygen. So this one takes priority. That means this is 1. This is 2. And this is 3. So it goes 1, 2, 3. It goes to the left again. That's S. Okay, I was starting to confuse myself. So it's 3S, 4S. Phenyl, 3S, 4S, 3,4 dihydroxypentanoate is the second one. Now, Dr. Carty's trying to throw us a huge curve. All right. So let's take this one one step at a time. I think we got time. I haven't been looking to see how many more slides we have. Have you? Okay, so we can take our time on this molecule. Okay, we have this nitrile group, and then that carbon is attached. I put that carbon in there just so I wouldn't forget it. And then we'll do the rest of them as imaginary. This is like so, and this is a cyclopentane. And right here we have 08. And we have here is carbonyl. Okay. All right. So what are our functional groups? We have a nitrile here, nitrile. And we're looking at priorities. Priorities are, this is going to be an ester. Right, so ester has the highest priority. So that means and we have a hydroxyl. And we have this is our prefix. Our first thing is cyclopentyl. Okay. And our hydroxyl, and then our nitrile. Okay, so if we start from this end, that's a 1, 2, 3. And this is not, actually, it won't be called nitrile with it, will it? It's cyano, excuse me. Nitrile is if it's a suffix. So this is cyano. That means this group is separate. So this is going to be propanoate. Right? Propanoate. And it's cyclopentyl. And cyano is attached at the 3. And the hydroxyl is attached. Hydroxy would be the prefix there. Was attached at, well, they're both attached at the 3. Yeah, the cyano and the 3 are both. So the cyano comes first, and then the 3 hydroxy. There, cut that out. So it should be, oh, and it's got a chiral carbon right here. So we got to figure out how do you do that? Okay, so and that's going to have to come after. This is the very first thing, the part that attaches to the propanoate, and then we do the chirality for this carbon right here. Hydrogen's in the back already, so this carbon, this one takes priority, so this is going to be number 1, and then this is a carbon, this is a carbon, but this carbon is attached to another carbon. This carbon is attached to a nitrogen, which is a higher priority than the carbon. So this side's going to be 2, and this is going to be 3. So it goes 1, 2, 3. That's S. All right, so at 3S, 3 cyano. Okay. Cyclopentyl. Oh, since we only have 1, we don't have to say where it is, right? If we put the S in front of the 3, this is redundant. There we go. 3-hydroxy propane. There we go. Oh, moving on. Acid anhydrides. For a symmetric acid anhydride, you name the molecule according to the alkanes that's attached to both sides of it. And our example here is, let's see, CH, the R group. Okay, that's a generic. What do we mean by symmetric acid anhydride? That means both sides of that oxygen are identical. Right? The R and the R prime are exactly the same. That's a symmetrical acid anhydride. If it's not symmetrical, then you name the molecule according to the alkanoic anhydride version. And we need an example. And this is a dehydration synthesis. The process of making the anhydride simply means you have to remove water to get the bond to form. So propanoic anhydride means that both sides are propanoic acid, and they're attached at their common oxygens. If you have an asymmetrical, then you say which side is which. All right. On one side, you have ethane. Yeah, ethanoic acid, right, would have 2 carbons in it, including the one that has the acid functional group. And then the other side would be the benzoic, right? We know benzoic acid, we know ethanoic acid, and alphabetical. B comes before E. So benzoic, ethanoic, anhydride.